All right, students. So we had some tough things today with proof by contradiction, and I wanted to start off by talking about the idea of the contrapositive. And I mentioned that's logically equivalent to the original statement, and that is the basis for some of the proofs by contradiction. And so I just wanted to show you that example and maybe break it down in a slightly different way that might help you understand it. So the example I gave in class was, if it's raining, then I bring an umbrella. And I claimed to you that that's the same statement as, if not an umbrella, if I don't bring an umbrella, then it's not raining. And one way that you can evaluate if statements are equivalent is by looking at the truth of them. And so you may not have seen this before, but you could make a table of the different possibilities. So R stands for if it's raining or not. U stands for if it's an umbrella or not. We're going to call this one up top. This one here is going to be statement one. This one down here is going to be statement two. And so we'll talk about whether statement one is true and whether statement two is true. So the first option here in the table is that it is truly raining and it had truly brought the umbrella. So if it's truly raining and I brought the umbrella, then statement one is true because I told you if it's raining, then it's an umbrella. Statement two is also true here because I didn't do anything to contradict that statement. The statement says, if not umbrella. Well, I'm not in the not umbrella world, so I can't say it's false. I have to conclude that the first statement is true. The second possibility is that it is raining and that I did not bring an umbrella. Okay, well, statement one is false then. Statement one is false because it says, if raining, then umbrella. Well, I put here true, raining, false, umbrella, so statement one is false. Look at statement two. If not umbrella, so my umbrella is false, then not raining. Oops, raining has a T there. So that would mean statement two is also false. So what I want you to be noticing here is that these two columns end up with the same truth or false, regardless of how I change the truths or falses with the raining and umbrella. There's two other combinations here. Let's look at raining being false. If raining is false, then umbrella could be true, or if raining is false, umbrella could be false. So let's look at the third row here. If raining is false, I don't have any information about statement one, so I am going to call it true. If umbrella is true, I don't have any information on statement two, so I'm going to call it true. Remember that the idea here is that you can only conclude a statement is false if you have information that contradicts it. So the fourth possibility of false and false here, if it's not raining, then not umbrella. That does not do anything to contradict statement one. And if not umbrella, that checks right here, then true. So what I want you to notice is that in all four of the combinations of raining and umbrella, we had a match between the truth value of statement one and statement two. Let's look at one other example here. Maybe let's do a more math example. If a shape has three equal sides and no others, then it's an equilateral triangle. And we flip that around by saying, if not an equilateral triangle, then not a shape with three equal sides. This right here is maybe a little bit silly of an example because it's just a definition. If a shape has three equal sides and no others, then it's an equilateral triangle. Well, that's what it means to be an equilateral triangle. So we could make the same sort of truth table as before. We have the shape, 3 equal sides. We have the equilateral triangle. We have statement 1, and we have statement 2. Same sort of idea here. If the shape is true and the equilateral triangle is true, then that makes statement 1 true. Doesn't contradict statement 2. If statement 1 is true, but statement 2, or sorry, if the shape has 3 equal sides, but we're not calling it an equilateral triangle, then statement 1 is false, and so is statement 2. Because the if part of statement 2 is not equilateral triangle, so that's what we're saying here, and not a shape, well, that's the wrong part, because we said truly was a shape with 3 equal sides. Down here, false, false leads to true because it doesn't contradict statement 1, and it leads to true because it agrees with statement 2. And then the last combination, false and true, does not contradict statement 1, and it also does not contradict statement 2. So we have the same truth table as before. You should try to play around with this idea. Another example I thought of on the drive home was, if it is Saturday, then it is not a school day. And the contrapositive of that would be, if it is a school day, then it is not Saturday, right? So just, I'm not going to write out the whole truth table, but you could write it like this. If Saturday, then not school. I'll put an H on there. And the contrapositive of that is school implies not Saturday. And I hope you see how those two statements are equivalent to each other. Okay, so that might help a little bit with the idea of the contrapositive. In another video, I'll do just a few proof by contradiction examples. So thanks. Please comment, ask for more, whatever you need, and we'll get through this.